Hi everyone, welcome to Easy Math. My name is Hassan Abbas and today I'm going to explain a small but important fact. If n square, if n is even, then n square is also even. So we want to show that when the square of a whole number is even, then the number itself must be even. Quick example. Let's say that n equals to 4. Sorry, n equals to 2. Then n power 2 equals to 2 to the power of 2, which is going to be equal to 4. That means 4 is an even number. But let's say that n is an odd number. Like, let's choose the number 3 since it's odd. For example, n equals 3. Then n to the power of 2 equals 3 to the power of 2, which is going to be equal to 9. That means 9 is an odd number. And a quick reminder about even and odd numbers. So if a number is even, then it is going to be 2 times something. But if a number is odd, then it's going to be 2 times something plus 1. For example, if it's even, then it's going to be just 2k, for example. But if it's odd, then it's going to be 2k plus 1. So this is just a quick definition, or let's say a reminder, of what an even and odd numbers are. Now I'm going to prove to you my point through contradiction. Okay, so a proof by contradiction is basically we temporarily assume that the opposite of what you want to prove, and that leads to something impossible or false. Then our assumptions must be wrong. So it's basically two things can't happen at once. In other words, when the logic breaks, that's the contradiction, and that's how we know the original statement must be true. So assume opposite will lead to impossible results. Which is going to lead to contradiction. Which leads to original is truth. So now I'm going to show to you how we prove this by contradiction. That if a number is a square rooted, if n is even, then when it's going to be square rooted, it's also even. As I said, 2 to the power of 2 is 4, which 4 is even. So I'm going to go through 7 steps in contradiction. Okay, step number 1. As you said earlier, start with the given. N to the power of 2 is even. So let's assume that n to the power of 2 is even. Okay? Step number 2. Now for the contradiction. Let's assume that n is odd. So n is odd. So as we said earlier, which is going to mean that 2k is plus 1. But remember, the k is an integer. Okay. Step 3. Now let's square root the 2k plus 1. So it's going to be 2k plus 1 to the power of 2. Okay, which is going to equal 4k to the power of 2 plus 4k plus 1. Okay, so we just expanded this part. So this is basically how we expanded it, okay? So now we're going to factor out 2 from the first two terms. So 2k to the power of 2 plus 2k also plus 1. Okay, so this is step number 4. Step number 5. This means if n to the power of 2 equals 2, then some whole number plus 1. As I said earlier, that an odd number is, for example, 2k, but must be plus 1. So for number 5, that's the form of an odd number, by the way. So let's write that n to the power of 2 equals 2, and then integer, because we said that k is an integer, so we're going to write integer plus 1, which is going to be n to the power of 2, which n to the power of 2 is going to be odd. Okay, but wait, we started by assuming that n to the power of 2 is even. How is it odd? Now we've shown it's odd. That's a contradiction. Okay, so basically number 6 is that this is a contradiction. Why? Because at the start we said that n to the power of 2 is even, but after we went through this process, we found out that 2 and then between brackets integer plus 1 is that n to the power of 2 is odd. So this is the contradiction. That's the contradiction. Okay, so we're at number 6 now. So we're just going to write that this is a contradiction. Okay, so our assumption that n is odd must be false. Therefore, n must be even. So, number 7, n has to be 7. Has to be even. My bad. That's the contradiction. So I'm going to show you the full contradiction part, and hopefully you understood it. Okay, now let's recap over everything we went through. We assume that n to the power of 2 is even, and n is odd, but that led us to say that n to the power of 2 is odd. That's a contradiction. It's not as we expected, not also as what you expected. So the only option left is that n is even. That's it. If n to the power of 2 is even, then n is even. Okay, so this is the whole process we went through. So a quick reminder, so it sticks in your brain. If n, I'm going to write it in red to emphasize how important this part really is. If n is even, if n to the power of 2 is even, then n must be even. Okay, so now we approved that if n to the power of 2 is even, then n must be even. But let's prove it. This statement is proved by contradiction, as we went through the 7 steps of contradiction. So if n to the power of 2 is even, then n must be even. So, and we also proved it by contradiction. And that's it for the video. Thank you so much for watching. Don't forget to hit that like button, subscribe, and stay tuned for more videos. Thank you. Bye bye.